Hi, my name is Nicole Hart Badilla, and for today's video we're going to learn about light sensing robot. Here is our roadmap for today's discussion. First, the background of the study, then an overview of the prototype, and last, the chemistry behind light sensing robot.
As we progress through our topic, we will learn how robots can impact our daily lives and how great that our world is constantly progressing by developing these robots. Now, join me as I uncover its significance and provide you with information that can help you form a relationship with this brilliant invention.
The background of the study. What exactly is a light sensing robot? The light-following robot can detect and track the light source as it moves. It is designed without the use of microcontroller to provide more accessible connections and a deeper understanding of the circuit.
As we all know, a robot is a mechanical device that can perform a variety of tasks on demand or according to pre-programmed instruction. This light-sensing robot is a well-programmed robot that can detect light and makes a movement based on what it receives. And its function is to follow the light wherever it goes.
What function does a light sensor serve in a robot? The light sensor is a passive device that turns the energy of light into an electrical signal. Because they transform light energy into an electrical signal, light sensors are also known as photoelectric devices or photosensors.
The robot has two light-detecting sensors, outfitted with LDRs, also known as light-dependent resistor. Light sensors are commonly used in robotics for navigation and object detection, typically by sensing the amount of reflected light. The operation of light sensors is direct because it generates an output signal that is proportional to the amount of light detected.
The overview of the prototype. What materials are utilized in the construction of a light sensor robot? First is the photovoltaic cells and photoresistors are the two basic light sensors utilized in robotics. Next is the motor DC, then the power source which is the battery, transistor, resistor, diode, and also connecting wires. Here's a clip that shows the actual materials used in a light sensor robot.
And then on the top of the robot, we have a battery pack and a breadboard with a circuit on it. You don't need to worry about exactly how the circuit works right now. We'll get to that later. And on the bottom of the robot, we have two motors that drive the robot's wheels and a third wheel that helps keep the robot stable. So if we come back around to the top of the robot, you can see the most important part of the circuit, which is these two light sensors that are sort of sticking up like a little antenna. And what these light sensors do is control the speed of the motors.
How the robot follows the light. The circuit of the robot senses bright light, for example from a flashlight. The course then transmits electrical impulses to the robot's motors, which causes them to switch on. The motors propel the robot's wheels, which allow it to move and steer. When the toy moves in a forward direction, it always observes any obstacle and light in front and on top of it. Here's a quick video clip showing how the four-wheel small robotic vehicle move with the help of a flashlight.
When I turn a flashlight on and aim it at the light sensors, you can see and hear that the wheels will start spinning. What this allows me to do when I put the robot down is steer it left and right using the flashlight. So you can see that when I put the robot down on the table, I can use the flashlight to drive it around and make it follow the beam.
Light sensor is a type of transducer that detects light and creates a voltage difference proportional to the quantity of light that reaches it. As I've mentioned earlier, light sensors in robotics can help with navigation and object recognition by monitoring light reflected off adjacent objects and determining their distance from the robot.
The chemistry behind this invention. How does the LDR photoresistor works? Sensor technologies transform changes in incident light into changes in resistance, with resistance decreasing as the intensity of light increases. They are constructed of a variety of materials, including cadmium sulfide, lead sulfide, and indium antimonide.
This resistor operates on the photoconductivity concept. It is nothing more than the fact that when light strikes its surface, the material conductivity decreases, and electrons in the device's valence band are stimulated to the conduction band. These incoming light photons must have more energy than the semiconductor material's band gap, causing electrons to jump from the valence band to conduction.
And that's the end of our discussion. Thank you for watching.